In the previous lectures, we discussed about the Shepard's bias formalism to construct of the Superfields for the Shepard's matrix theory. First we discussed about the two specific superfields, which is the chiral superfields and the vector superfields. We already found that the chiral covariance derivatives dA in terms of sort of the some Grossman variable, and if we give such a constraint, covariance derivatives from the general superficies equal to the zeros. Then that is the definitions of the left chiral super left-handed chiral superficies. And similarly, also we can define the right-hand chiral superficies without the no dot index and nearby index. Then such a constraint will give the right-hand is the chiral superficies. And under such a constraint removes some specific components featured in the general superfield because the chiral covariance derivatives in the space-time translation basis x mu go to the y mu such a translation basis that is just equal to the minus partial I dust, which is just the Gaussian variables derivative. So there will be no set of dependence in the such a left-handed chiral superfields in the such a y basis. So there will be just only set as Gaussian variables component with some will remain. So we can write the left-handed chiral superfields in terms of the translate space-time wise and the Gaussian variables to set as, and there are no set of dependence. So there are some scalar fields I, spinner fields psi, and some accelerized base. And such accelerized base can be removed by the equation of the light. And if the such a pies are the left-hand chiral superfields, then the product of the two left-hand chiral superfields is also chiral superfields by definitions. And the second example is the vector superfields. The constraint is real conditions. The V is equal to the V dagger. Then it removes some specific components. There will be some same terms for the Hermitian conjugate system. For example, there are zetas, pi terms, and there should be the zeta bars and pi bar term. And if there are some quadroptic Gaussian variable zeta and scalar fields, then there should be the zeta bars quadroptics, and the and star such terms. And similarly, there will be some of the Hermitian conjugate term for other complex terms should be the associated with Hermitian conjugate term. And if we give some of the specific guises, then we remove the such as some component base of the vector based more. And there are also some examples of the vector superfields. The pi daggers plus pi is the vector superfields because the complex conjugates of the pi dagger plus the pi is the itself. And similarly, pi daggers the product of the pi is also vector superfield because all terms of the complex conjugate series equal to itself. And such a pi dagger set of pi is a very important term to construct the vector superfields from the chiral superfield. And we can give some of the Boston gauges, some specific gauge condition. Then there's some component fields can be the benefit. So we will use such a Boston gauge vector superfields from now on. So such a Boston gauge is contains the some spin fields lambda. In the standard model terms, it is called the gauge, which is the superpartners of the gauge boson. And there will be the gauge boson V mu, which is set up by sigma mu polymatrix and the zeta. And there will be the system of acceleroids with the quadratic term zeta and the zeta bar and zeta bar. And so this is called the vector superfields, and we can construct sort of some supersymmetric arrangement from this vector superfield. And it's partially the the scales of the Boston vector superfields are given like that. There is a V mu and V mu term, but the cubes of the Boston vector superfield is equal to the 0. So exponential of the Boston case is has a finite expansions because V cubes is equal to the 0, and the such exponential of the Boston case is a very important term to construct about the gauge theories in the supersymmetric supersons. There are still some of the additional important quantity, which is the supersymmetric phase strength or the Superfield strength. That defines as a stabilis I equal to the sum back test 1 over the 4, and the Chiral covariance derivatives dd vast and the d of the vector superfield. And also we can define sort of the dot index and the bar index. And such as some superfield strength is satisfied the left handed Chiral superfield condition, which is the Chiral covariance derivatives of the superfield strength is equal to 0. And it's partially the such as some superfield strength contains some of the field strength in the standard model, which is defined as upper mu is equal to the partial mu v nu minus partial nu and v mu, which is some of the kinetic term for the spin one gauge boson. And if we calculate twice of the such a superfield strength, then there will be the kinetic terms of the gauge boson will be appear. So also there will be kinetic term for the gauge zeros, which is some of the spin half barometers. So this is the spinner, so it has some of the Dirac forms of the kinetic terms which appear. And such as this, our discussions of the Chiral superfields and the vector superfields in dice will be used to construct the supersymmetric Lagrangians. There will be some of the terms and of terms which is such as superfields is the Chiral vector superfields like